Hello everyone, we have seen how combination of phase, parts and octest on a KMAP can be used to obtain a simplified expression. A pair of ones eliminates one variable, a pair of ones eliminates two variables, and an octest of ones eliminates three variables. In general, when a variable appears in both complemented and uncomplemented form within a group, that variable is eliminated from the resultant expression. Variables that are same in all with the group must appear in the final expression. Each group gives us a product term, and summation of all product term give us a boolean expression. Therefore, we can say that each product term implies the function and hence is an implicant of the function. All the implicant of a function determined using a KMAP. From the above discussion, we can outline generalized procedure to simplify boolean expression as follows. First, whatever the equation they are given, draw the truth table. From the truth table, we can make the KMAP representation. Plot the KMAP and place ones in those cells in the truth table corresponding to the ones in the KMAP. Sum of product expression, and place zeros in other cells. Third one, we have to make K mapping. So KMAP mapping we can do three methods. First method, check for those ones which are adjacent to only one other that encircle such pairs. Second one, check the KMAP for adjacent ones and encircle those ones which are not adjacent to any other ones. These are called isolated one. And third one, check for largest number of the groups, quads or octest for adjacent ones, even if it is contain some ones that have already been encircled. While doing this, make sure that there are minimum number of groups. Once you are done mapping, fourth one, go for equation solving. Just whichever the mapping done, that particular equation selected, whichever the same portion in that row and columns, only select, whichever different, ignore it. Once created the equation, start the logic gate. Do the logic gate for the SOP portion. This is how any KMAP problem can be solved. We can go with some example. You can understand how actually the KMAP can be solved. First example in this, we can say, take that, plot the Boolean expression y is equal to ABC bar plus ABC plus A bar B bar C. The template already I have taken. In this template, the first one we know that it is actually truth table you have to do. Once truth table done, second one we are doing KMAP. Once KMAP completed, simplify the equation and do the final equation. Once final equation done, create from that equation to logic diagram. These are four procedures usually we can do it. In this I have taken some template. This is common for the any problem. Just we can put the values according to the our problem. Let's check what is our problem here. Here A, B, C bar. So A, B, C bar means A is 1 and B is 1, C is 0. So 1, 1, 0 is where we have to check, and that condition we have to make as a 1. The second condition is ABC. ABC is nothing but it is a 1, 1, 1. So wherever 1, 1 is there, make it logically high. And and last one A bar B bar C. A bar B bar means it is 0 0, C means 1. So 0 0 1 you have to make as a high, and whichever portion not there simply fill with the 0. This is how you can draw the any equation into the truth table. Remember that your equation should be canonical form. That means all the three variable has to be present here. Else you have to expand to the canonical form, then only you can draw the truth table possible. This is the first procedure. Once you done truth table, go to second procedure, try to fill the KMAP. Wherever 1 is there, fill that portion. It is actually the one portion is there in 1 0 0 1. We know that 0 0 1 is this portion 1, so we can make 1 here. Okay, and then we have 1 in the 6 and 7s. So 6 and 7 here, so we can make 1, and other all the portion we can make it 0. In this way we can represent the KMAP. Once we are represented KMAP, now our aim is to make that grouping. The such a grouping that where the 1 present. In this, the only one of this portion we called as a implicant. It is not connecting to the any group. So we are doing it is single because there is no adjacent ones. All the portion it is 0. Either we can do it with 0 part 0, 3 part that is 0, 5 part that is also 0. So we can make it single one. If you come to the 7, yeah, it contains 6 and 7 together. So we can make as a together group something like this. So from this KMAP we can do two groups. The first group, whichever equation as it is we have to write. What is the equation for this one? It is nothing but A bar as it is, and then we have B bar C. This is if it is no combination, we will get all the three variable. Here 1 is there, so the A is common in this case, so take A. But in this BC bar, so B is a common, C bar get cancelled, so we can call this one as a AB. So our equation is formed here. Our equation something like that: AB plus A bar B bar C. From this equation we can draw our circuit diagram. So circuit diagram, usually remember that in our case it is always either A or A bar can be given. So in this template I have taken as a first portion, then A bar in the after inverter. Okay, so this portion is B bar and this portion is C bar wherever necessary. And always remember we are doing as a SOP. So in this case we require as a first product. So product we have to use AND gate. So first portion all these we are using AND gate. Then we are summing with that using OR gate. Always remember in SOP the each individual is AND, then it is OR. So structure is same as I shown here. Now come to our first equation AB. So I will go with the first portion. Here this portion is A from this line. This portion is A and one more portion, this is B. So you can say somewhere here. Now take the line for B1 here and A. So this is known as, here we are getting A and B because of A is we are showing here, B is we are showing from this line. Next we have A bar B bar C. So we can take that in this second case, here it is A bar and this is B bar and this is C bar. So C bar is there and B bar also there, A bar also there. So this equation is A bar B bar C bar, and these two we are adding. So from first one we are adding, and from second one also we are adding. You can take something like that, straight line. So wherever the dot line is there, it is connected, and all these portions are not required from our portion now. So these two are added and OR gated. So we got final answer is X. This is the way you can make as a logic gate development. This is for example 1. Now we can move on the example 2. In this example, if you are taken as a bar, B bar, C bar is nothing but 0, 0, 0. A bar, B, C means 0, 1, 1. A, B, C bar means 1, 1. Sorry, B bar means 0, 1, 0, 1. So 0, 0, 0 means the first case it is 1. Next 0, 1, 1 means 3, it is 1. 1, 0 means 5, it is 1. All the other case simply fill zeros. Now draw the KMAP wherever present. 0, 0, 0 means 0, so draw here. 0, 1, 1 means 3, draw here. 1, 0, 1 means 5, draw here. Listen carefully. In this case, we don't have any mapping possible. So this 3 cannot be mapped with anywhere. This is the single map. This is also single map. This is also single map, because I cannot do any diagonal. So this particular equation cannot be simplified. So whatever answer we have, the same equation I have to get here. So my equation is A bar, B bar, C bar plus A bar, B, C plus A, B bar, C. So apply according to this. In this case, first if you go with here, it is A bar, so this portion is A bar, then B bar is this portion, and then C bar is this portion. So it is A bar, B bar, C bar. Next A bar, B, C means again A bar is this portion, B means this portion, C means this portion, right? So it is ABC. Again ABC bar means the next one, this is A and this is B and this is C. From this we can say that we are getting, and only take this 3 AND gate and form the X. This is how we can write the logic diagram. Sometimes you will get such a cases we cannot do any simplification. For that, this is the best example. Next we can move on somehow more numbers. In this case we called as a B bar C. A means 1, B bar means 0, C means 1. Next A B bar C means 0, 0, 1, and A bar B C means 0, 1, 1. A B bar C bar means A is 1, other are 0, 0, and last one is all zeros. So all zeros means it is 1, and 0, 0, 1 is present, so 1. Then 0, 1, 1 present, so 1. So we completed 0, 0, 1, 0, 1, 1, 0, 0, 1, 0, 0 and 1, 1. These are 1. Other portion 0. So total 5 equation there. So 5 ones. From that simply fill with your KMAP. So 0, 0 is 1. Then 0, 0, 1 is 1. And 0, 1, 1 is 1. Next 1, 0, 0 is 1. 1, 0, 1 is 1. Now in this case, how to do the mapping? Usually in this case the 2 mapping is possible. Always remember that you have to do such a mapping that it can be maximum numbers. In this we can do maximum numbers here 4 together. So this is the one mapping, and 1 is left in third, so one more mapping we can do it. Simply we can do like that. From this we have equation is something like, here it is BC and it is B bar C. So C is common, B is cancelled, so take C. In this A bar is common, so we can call C A bar or A bar C. In this fourth term, A and A bar get cancelled because of this, and B bar is common. In this case both are B bar common, and C bar is different, so it cancels. So our final answer is B bar. So simplified version here is A bar C plus B bar. See how it is biggest equation can be solved very easily and very less simplified version. Now how to draw this logic diagram? Simply check A bar portion. This is actually A bar, so make it A bar here. Then we have C means somewhere here, make it, okay. And next we have only B bar, so only take this portion and take this and this as a your x value. This is how you can draw the logic diagram also. Once again we can do it different step like this. In this case, first you have to do the all the portions wherever one you have to fill. So we have one here. In this case I can do either this one 2 and this one 2 and this one 2. The issue is this is wrong. Why? Because always if maximum number possible, don't go for the minimum number. For that case we can do it as a this 1 and after that 4 ones. From this already we discussed, we got from this B bar and this we got A bar C. Next we can move on the some 4 variable, somehow interesting how we can do all those stuff. In this case we have A bar B bar C D. So A bar B bar means it is 0 0 and C means 1 0. This is the one case. So 0 0 1 0 means this portion is high. Then A bar B C bar D. A bar means actually 0, B means 1, C bar means 0, D bar 0. So 0 1 0 0. 0 1 0 0 is this condition is high. Next go with the here A B C bar D. So AB means 1 1, C bar D means 0 0. So search 1 1 0 0 in this case, make it high. And in this case AB C bar D, so 1 1 0 1, 1 1 0 1 where it is, check it out, and that case make it high. And last two conditions are A bar B C bar D. A bar is 0, B C bar D. So it is 0 1 0 1. Search 0 1 0 1. It is somewhere here, make it high. And last one, it is A B bar C bar D 1 0 0 1. So 1 0 0 1 is here 1, and all the other condition fill the zeros. This how we can make the truth table. Truth table, always remember that first fill the 1, it is easy. Wherever not present, make it zeros. Fill the KMAP with truth tables. So 1 present is 2. So here 2 is 1, then 4 is 1, then 5 is 1, and then we have 9 is 1, then we have 12 is 1, 13 is 1. Just fill these values. So in this case 2 is 1, 4 is 1 here, 5 is 1, then 9 is 1, and then 12 is 1 and 13 is 1. Okay, and other you have to fill with 0. Here actually I am not filling all those stuff. You can fill that. From this part you can check what are the particular mapping is possible. If you take this one, this is not adjacent to anyone. Adjacent is this side, so nothing but 0, here nothing, and 6 also not there, 7 also not there, 3 also not there, and upper portion 10 also not there. Okay, so it is called single one, so make it single group. And in this case here this 4 we can easily do it because 4 option is there, do it, and one more this portion we can do something like that. So from this you can form the equation. Here how it is equation, the first this one actually everything, that is nothing but A bar and B bar, then C bar D bar, because it is only one, so all the 4 variable is present. If you are taking with the 4 numbers here, then usually what happens, in this case A bar and A are different, so cancel out, B only we will get. And in this case here C bar is common, D bar D get cancel out, so it is C bar. So from this 4 we got BC bar, and in this 2 we can check, here again B bar get cancelled, so we are getting as a from this part. Okay, so take A here, and what happens to this, here C bar D is together only, there is no cancelling out, so take C bar D as it is. Here observation is that if it is 1 numbers, then all the 4 variable present. If 2 numbers, then 3 variable present. If 4 ones, then only 2 variables. If 8 ones, then only 1 variable. From this you can make it as a simplification. Now take all this together. So we will get equation something like that. A C bar D plus we have B C bar plus we have all the 4 A bar, B bar, C bar, D bar. So from this we can draw the logic diagram. So how to draw the logic diagram? A C bar D. A means here the first one. Okay, and then we have C bar. C bar is this portion, and then we have D. D is something this portion. So this is the first one. Second one, BC bar. BC bar means B is here, C bar is this one, and last one A bar, B bar, C bar, D bar. So we will take all the bars. This is A bar, this is B bar, this is C bar, this is D bar. So we are using 3 AND gate. Take it these 3 AND gate together and make the OR gate portion. And this is how we can draw the 4 variable diagrams. Okay, I am using all the template ready, only filling with the according to the given equation. You can do it in step by step also. In this, check it out in this portion. Here wherever 1 present we are done, that is the first portion. Okay, after that wherever single ones we are done, then we are done where double ones, then we are done with 4 ones and simplified. This is the easiest method you can do with that, and always fill other value with zeros. Okay, so this is how we can solve the KMAP equation. Next we can move on one more example. Here instead of equation, now they are given in the summation form f of abcd, that means function of abcd 4 variable and values given 0, 2, 3, 8, 10, 11, 12, 14. If they are given something like that, it is very easy to make us the truth table and other part. If it is they are given in equation form, we have to convert into this form and we have to make it truth table. Okay, now make it 0 position is 1 here, then 2 position is 1, 3 position is 1, 8 position is 1, then 10 position is 1, 11 and 12 and 14 position 1, and all the other position you have to fill with zeros. Now we can make as a KMAP using this truth table. So from the given example, the 0 is present here, next 2 is present 1, 3 is present 1, 8 is present 1, 10 is present 1, 11 is present 1, and then search for 12 and 14. This is how you can make it 1, and other portion whichever not there 1, simply make it as a 0. So that portion fill with zeros. Now once completed ones and zeros, now your work is make mapping. Here it is very difficulty to map if it is such a way widely taken. So very careful with the vertical and horizontal, up and right, left. So if you take this position, you have to make such a way that all the 4 here actually possible. All the 4 circle is there. This and this we can make it like that, and this also we can make together. So this is actually one group. Next, second group can be made 2 part. So we can make something like this, the 4 members this side. Okay, this is down and up portion. Okay, this is the another. This is possible because this one and this one not joined to any group, so we can do it. Okay, and one more possible here, that is this side also we can make each one. Here you may ask questions, what first I have done here, that can be removed. That is 1, 1. This is not included any group, so we can do that group also. So from this we have made 3 groups. Each group we can check it out what is our equation. So this group actually is merged with 14 and 10, 12 and 8. From this we can say that it is C D bar and C bar D bar. Here D bar is common, C is not common, so D bar we will get. In this portion we have AB and AB bar, so B bar is different, so cancel out, we will get A. From final this equation we can say it is AD bar. Same way we can go with this red diagram. In this we can say that it is actually 3, 2, that means CD and CD bar portion. Here D bar is different, so we are getting C here. And in this portion it is actually 2, 3, 11, 10, so A bar, B bar and AB bar portion is involved. In this B bar is common, A bar A is different, so you can take B bar. From this we can say that we are getting C B bar. Then we will go to the first what we mapped from all the 4 portions. So if you go with that 4 portion, it is involved actually 8 and zeros. So we can say that it is A bar, B bar and AB bar. So here B bar is common, so take B bar. And in this if you take C bar, D bar and C D bar it will take. So in this case the D bar is common, so take D bar portion. From this portion final answer we can say that we have one is B bar D bar plus we have D bar A plus we have CB bar. This is what equation we got from this expression, simplified version. After simplifying this, just draw the logic diagram. In this case, it is first is B bar D bar. So B bar usually we says this portion and D bar usually says this portion. Next we have D bar A. So D bar is again this portion and A is first one. And the last one is CB bar. So go to C portion. This is C and B bar is this one. So from this we can draw the logic diagram. So we have using 3 AND gate. So use this 3 AND gate and we are getting as a X in OR gate. This how we can also simplify if you are given in the number format. Here I have done that. Once again is shown here same answer what you have to get. Already we got B bar D bar plus A D bar plus B bar C. So our answer is proper. You can more flexible to do these stuffs. There is a mapping is difficult. For that reason I am doing more examples. Let's go for next example which contain 1, 5, 6, 7, 11, 12, 13, 15. So wherever the part is there make it 1. 1, 5 is there and 6 is there and 7 is there and 11 is there and 12 is there and 13 is there and 15 is there. Whichever not there, that fill with the zeros. Now form the KMAP from the truth table wherever 1 present. From the boolean expression we can see that the given is in 1 and 5, 6, 7 and then it is given 11, 12, 13 and 15. So if you given like this, other portion fill with the zeros. Now listen here, what we can do from this, usually if it is something like that, we will attempt to do this all 4 ones together and then we will map it the 2. If you do something like that, it become wrong because these 4 ones is not become any individual mapping possible. So hope it is check it out. I can do here these one together and then I can do these ones. and one more, I can do something these ones, and I can do something these ones. Now if I try to do these 4, what happens? These 4 already is there in one group. The rule says that anything you have to do in group, any one should be not included in any group. But here all the ones are included some group, so I cannot do these 4 together. This is very, very important. First you can try with the smallest number, then you can go for the maximum. You can understand that if it is anything left, then only we can make it that 4 members. So from this equation we can say that here it is C bar D as it is, because it is only one row, and B bar is cancelled out, so it is A bar. And from this equation we can say that A bar B is common and C is common, because D bar get cancelled. From this we can say that it is CD common, and then we have B bar B get cancelled, so A is common. And the last equation, this one, the AB remains same, and then it is C bar D bar C bar D, so C bar is a common one, D bar D get cancelled, so you will get C bar. From this, if you write in the equation portion, you will get something like that: A B C bar plus A C D plus A bar BC plus C bar D A bar. Okay, this is the what 4 equation we got. From this we can draw the logic diagram for this. So first take ABC bar. So A is here, B is here, and C bar is here. Next case ACD. So all are uncomplement version. So here is A, and this one is C, and this one is D. And then A bar BC. So A bar is this portion, and then B is actually this portion, and C is actually this portion. So it is called A bar BC. And last one, C bar D A bar. So C bar is here, D bar here, and A means this portion. From this we can say that how we are drawn the logic diagram. So we are including first 4 here, and other we are not using. So take this 4 only. This is what you are getting output. Okay. Here in this portion they are calling Y. We are taken as a X. Better to take whatever they are given. Okay. Better to take as a this portion is Y only. Okay. So this how we can draw it. Next Boolean expression. Here this is somehow complex, because in this equation we are calling this is not a non-canonical. Why? Because this portion not contain one term called C. Okay. So canonical means each variable should be there in each equation. Same way in this portion also I don't have particular one variable. So we cannot draw the truth table from this portion. If you are not draw truth table, so KMAP also not possible. In this type of Boolean expression, the previous method what we have done, we have to convert this one into the canonical form. Then only we can make as a truth table. So convert this A bar B bar D to the first canonical. So we are including C plus C bar. Next ABCD as it is take it, and third portion A bar BD again include C plus C bar, and ABCD bar as it is. If you make the expanded one, this first one become A B bar CD because of this C, and next one A B bar C bar D because of this C bar, and this one as it is I am getting. In this first it will take C, then it will take C bar portion, and this portion A B C D bar as it is. From this we are getting as a final equation. When you got final equation, you always think that how to convert into the truth table version. So in this case, the truth table is actually what? Here A bar means we can call it as a 0 and B bar is 0, 1, 1. So A bar is again 0, B bar 0, C bar 0, D 1. A 1, B 1, C bar 0, D bar 0. A bar 0, B 1, C 1, D 1. Again A bar, B, C bar, D. Again A, B, C, D bar. From this we can say that wherever this present, make it 1. So 0, 0, 1, 1. So in this case 0, 0, 1, 1 is this, and 0, 0, 1 means here, and then 1, 1, 0, 0 means here, then 0, 1, 1 means 7 portion, this one here, and then 0, 1, 0, 1 means 5, then 1, 1, 1, 0 means 14. We have to get somewhere here. Now check with the portions wherever 1 present. Now try to fill with 0 present wherever 1 not present. Now fill the KMAP using this truth table. In this truth table, the 1 is present, 3 is present, 5 is present, 7 is present, and 12 is present, 14 is present. According to that, fill it. 1 is present, 3, 5, 7, 12 and 14 present. So this is 12 and this is 14. From this we can do the grouping wherever the possible. So usually it look like we can do grouping for these 4 together and then these 2 possible. Okay, it's like this, something like this. So when you do like this, from this group we are getting as a C bar, C get cancelled, so D is common, and here B bar B get cancelled, so A bar is a answer. From this we have actually 14 and 12 means C bar D bar from this and C bar D bar here. D bar is common, C bar get cancelled, so D bar. And here AB is both present everywhere, so it is AB D bar. So final answer is we have AB D bar plus DA bar. From this equation we can draw the logic diagram where the first one is A present, next one is B present, and last one is D bar present. Same way DA bar, so here this is the D portion and this is the A bar portion. Here the first 2 only required, so we got X answer. This is how you can plot the truth table and KMAP and logic diagram from the equation possible. From this you have to remember that any equation given such a way that it is not in canonical form, your aim is to convert into the canonical form, then only you can draw the KMAP. Else it is not possible. We can try more problems. Let's check it out. Next problem is 0, 1, 4, 8, 9, 10. So in this 0 is here, 1 and 4, 8, 9, 10, and other portion fill with zeros. Now represent the truth table 1 into the KMAP. So we have present in 1 and 0 and 4, 8, 9 and 10. So total 6 number of ones and other fill with the zeros. So how to do the grouping here? Here this one is we can make with the below portion that is this ones. So we can easily make this 4 portion. Once you done 4 portion, let's check it out. Is there any other possibilities? Here we have present this one in the 4, so we can make this only 2 possible here. And then we have one more portion called as a in this 10. So this is not a single one. We can make with the 8 also. So if you go with here, this we can make grouping like that. If you do something like 3 groups, now take the equation one by one. From this equation, it is 10 means C D bar, and 8 means C bar D bar. So C get cancelled. You can go with the D bar. And then here AB bar is common. So AB bar as it is. So we have AB bar D bar. And in this portion where 0 and 1 we can take something like that. It is C bar D bar is common and B bar B get cancelled. So it is A bar. The 4 ones present this equation we can take as a C bar D bar C bar D. So C is common here, D bar D get cancelled. In this 0 zeros and 1 zeros, so B bar is common here, so A bar get cancelled, so it is B bar. From this equation we can say that we are getting C bar B bar as a one equation plus D bar A B bar is another equation plus we can take as a C bar D bar A bar. From these three equations we can represent as a logic diagram. So C bar B bar means where it is C bar present this portion and another one is B bar. So B bar is this portion. Next one D bar A B bar. So D bar is this portion and A uncomplemented version and B bar is something this one. Then we have C bar D bar A bar. So all are all are complement. So it is C bar D bar A bar. So here A bar, here C bar, here D bar. C bar D bar A bar. So first three we are taking, take this as a logic gate. You will get the final x value. In next problem given, it is f of w comma x comma y comma z is equal to summation of 0, 1, 4, 5, 9, 11, 13, 15. So wherever present as a 0, make it as a high, 1 high and 4 high, 5 high, 9 high and then 11 high, then 13 high, 15 high and all the other portion fill with the zeros. From the truth table to KMAP, wherever present make it 1, 0 is 1, 1 is 1 and 4 is 1, 5 is 1, then 9 is 1, 11 is 1, 13 is 1, 15 is 1. So in this portion wherever 0 present make it as a 0. Now what are the possible group here? If you look like this, we can make one group something like that. This is the 4 ones. Okay. Next, we can do similar way another group here, something called as a this one. Okay, this 4. And it also we can do one more group here. If you do something like this, this is also 4 ones possible. But listen carefully, if you have done these 4 ones, all the ones are already there in some group. So this rule is not satisfied. So this one don't take. And other 2 only take it. This is very important. Any new group you are doing, any one has to be present that is not included in any other group. So we can check with these equations. So we will take first red one. In this C bar C is different, so D is answer and here A is common, B and B bar get cancelled. And next 4 one we have C bar and D bar is there, another one C bar D, so here D get cancelled, we have C bar. And next one, in this portion we have B bar B get cancelled, so A bar. And the important version, if you take the equation from this portion, that is we are done 4 ones, in this actually what, all the A bar B bar get cancelled. See, A bar is there and here A is there, get cancelled. Here A bar is there, here A is there, get cancelled. B bar B get cancelled, B bar B get cancelled. So if all ones, this all the portion will cancel. So we will get only C bar D. But this one we are not taking. Why? Because there is no one single one which is not included in any other group. So ignore this one, don't take it. If you take, that become wrong. Final answer, we can say that it is C bar A bar plus dA. So draw the diagram according to this one. Here A bar is somewhere here and C bar is somewhere here. This is the first one. Second one is dA. So A is here, okay, and D bar is D is here. So these are two equations. Only take two argued and we will get the final answer. And whichever not there, when you are practicing, don't write this one only, okay. Just I have taken for template for all the part, so don't use it. Just ignore this one. Only take these two and get and take output enough. Somewhere X bar is required, so that time you can do the NOR gate in the output side and you can do this stuff also. So if you take this portion here, so this is actually called as X bar. Okay, whenever necessary you can do that stuff. You can do one more last problem here. How to solve this type of problem? It is similar to previous, only here mapping is challenging. So go to the mapping how we can do. Here wherever the present, make it 1 as usual. 0 is 1, 2 is 1 and 5 is 1, 7 is 1, 8 is 1, 10 is 1, 13 is 1, 15 is 1 and all the other portion fill with zeros. Now KMAP representation, wherever 1 present, it is present in 0, present in 2, present in 5, present in 7, 8 and 10 and 13 and 15. Okay. Now how to do the grouping for this one? This one actually look very easy to do the groupings. So we can do this for 1, okay, and then here these all the corner we can take 4 like this, okay. Even you can take upper part also, down part also possible, or you can take like this also. So the equation for this one we have, actually it is C D bar considering and here C bar D bar. So D bar is common, so my equation is D bar. In this portion, if you take this portion A bar B bar and A B bar, so B bar is common, so my answer is B bar. Now we can take this 4, here the C bar C get cancelled, so D is my answer. In this B is common, A bar A get cancelled, so B is answer. The final answer is C, it is D bar B bar plus DB. So you can do very easily this one. So D bar B bar means here we can take D bar here and this one is B bar, okay, and DB means this one is D and this one is B. So only 2 gates, so draw the logic gate. This is how we can do this stuff for this type of problem. Next, some exercise problems. If your people are interested, do it yourself. In this example, listen carefully. I have taken output is P is equal to F of RSTU. So you cannot do as here as X, make it this one is P, and instead of ABCD, make it as a RSTU. Okay, and these all the portion change it, okay, according to the RSTU. And the given is 1, 3, 4, 6, 9, 11, 12, 14. According to that do it. Again here this portion also ABCD is replaced with RSTU and X and X bar replaced with the P, and here also the X is replaced with the P. Okay, these changes you have to do and try to do it yourself, mapping, and finalize the equation, and then you can get the logic gate also. Previously whatever the procedure done, same procedure, try to do it. One more example you can do it. One more example you can do it. In this case, the D is given actually. So the D is given actually here and function of wxyz. So instead of ABCD, take as a wxyz. Okay, and the given is 5, 7, 8, 9, 12, 13. Those portion make it 1, other portion make it 0. And here whichever the portion is there in the KMAP, this all change with the wxyz. Okay, and here instead of x you can do it as a d. Okay, just variable change according to the given answer. You have to change the variable. Here instead of ABCD, change to wxyz, and instead of xx bar make it d and d bar. Okay, once you completed, first make the truth table, then convert into the KMAP and finalize the answer, then go to the logic diagram. This is how we can simplify the any given KMAP into the boolean expression.